Hey Sharks, this is Mr. O. We're back with the final part of matter, which is properties of matter. The notes are a little bit different this time. I basically gave you an outline. On one side of the paper, there is a top and bottom, so the paper is cut in half. And on the other side, you have a T chart, but actually there's three on each side, not just a typical T chart. So if you have the holes on the left, you're looking at the side of the notes that has a top and bottom. In the top box, you're going to fill in two different things. First thing, this is physical properties of matter, which is the third part of the unit. And the other part that will go in that top section will be what physical properties of matter are used for. They're used to describe, identify, and classify all types of matter. People use physical properties all the time to describe people, things, cars, clothes, music. This is no different. So on the top part of that notes, this slide will go on the top part. Now, on the bottom half of the notes, you're going to cut that bottom half into two sections. Draw a line through the middle. On the left side, you're going to put physical change. You're going to identify the definition of physical change. That is a change, the form of matter, not its identity, meaning its molecules and elements, meaning the matter's changing, but its identity is not. A good example of this would be changes in phase, or if I simply told you to take a piece of paper, cut it up, it's still little pieces of paper, it's just smaller in size. So that's a physical change. On the other half of the front side of this bottom section, you're going to put the opposite of a physical change, which would be known as a chemical change. This is when two or more substances combine or decompose, which means break down, to form something new, which is also known as a permanent change, which means once this happens, you cannot go back to it. Some examples of that would be burning that paper, because once you burn the paper, there's no way of getting that paper back. And also baking a cake. Once you mix those ingredients up and you put them in the oven, those ingredients will never be flour again. It is a cake forever. So on the front, this is the last part for the front. So on the front, on the top, you should have physical properties of matter and the description of that. And on the bottom, you should have two sides, physical change and chemical change, the definitions and also the examples. Let's move on to the back. On the back, you have what looks similar to a T chart, but what we're going to do is we're going to work down the left side. So on the left side, the top box, you're going to write in independent properties. That's the only thing going in the top box. The box below that, only thing you're going to write in there, independent properties stay constant. If you don't know what the word constant means, it means they stay the same. These are properties of matter that will never change no matter what. So they are independent no matter what, they will stay the same. Down below in the bottom section, the biggest part of the section, you're going to have four different independent properties, and two of them I will define, and two of them I think are self-explanatory. The first one is density. So density is an independent property. To find density, you literally find the mass and the volume of something, and you divide those two numbers. That's what will give you density. This goes back to the beads in the bottle activity. So density is an independent property. The next is solubility. This is the ability for something known as a solute to completely dissolve in a solvent. Universal solvent is usually water. I always think of sweet tea. When you make your sweet tea and you boil that water and you put that sugar in that tea, when that sugar completely dissolves into that water, that is solubility. Okay? If you put sand in water and you keep shifting it around, that sand never goes away, that's not solubility. The third property is melting point. This is a self-explanatory one. It's the point at which something melts. And the last one is boiling point. This is at the point at which something boils. A lot of people will say, well, what's freezing point? Well, freezing point is with melting point. Obviously, when something freezes, it's not melting anymore. And when something's not frozen, it starts to melt. So melting point and freezing point are the same. So your left side, the top box will be independent properties. The middle box, it says stays constant and the same. And then the bottom four are four independent properties that you need to know. These are properties that you use to identify things, meaning you use independent properties to identify. They both start with I, independent, identify. Right side is dependent properties. I underline the word depend because it depends on the object. So just like the left side, the right side, the top box is going to be dependent properties. The next box down is the definition of that is they can change depending on the object. It depends on the object, so it can change all the time, meaning the same piece of gold can have several different dependent properties, but all the same independent properties. And then down below, you have four things, which are mass, volume, shape, and color. There's no reason to define them. We defined them before. And that'd be it for these notes. We will talk more and start doing labs about these notes on Monday. Enjoy the weekend. Talk to you later. See you.